Okay, so we've got the linear part. What's a system of equations? A system of equations is a collection of equations that must be solved simultaneously. We want to solve all the equations at the same time. With the same solution. A solution to a system of equations is a point that solves all the equations at the same time. Okay, so let's look at a simple example. Let's say we have x plus y equals 2 and x minus y equals 0. Okay, now to indicate that these two equations are part of the same system, a lot of times we will put on one side this curly brace that indicates that these two equations go together. Okay, or that all the equations in the system go together. In this case, there's only 2 in the system. So what would be a solution to the system? So it probably doesn't take you very long to identify one of them, even without resorting to algebraic means to find it. xy equals 1, 1 is a solution to the system. Because if I plug in 1 for x and 1 for y here, the equation's true, right? 1 plus 1 is 2. And if I plug the same point into the second equation, 1 minus 1 is 0. It also makes the second equation true. So this one point is a solution to both equations and therefore a solution to the system. Okay? Here's a point that's not a solution to the system. The point 2, 0. Now, it does solve the first equation. If I plug 2 in for x and 0 for y, the first equation of the system is true. But if I plug the same point into the second equation, the equation is not true. So even though it solves the first equation, it doesn't solve the system because it doesn't solve all the equations in the system. Okay? Let me pull up a graph of this so we could see exactly what's going on here. Okay, so let me pull it over here. So our two equations are x plus y equals 2 and x minus y equals 0. And so these two lines represent, they're the graphs of the two equations. Okay, the blue line going from top left to bottom right is the line of the equation x plus y equals 2. The points on the line represent all the possible solutions of just this one equation. Every point on this line, on the blue line, is a solution to the equation x plus y equals 2. If I plug it into just that equation, it makes that equation true. Similarly, all the points on the orange line are solutions to the equation x minus y equals 0. If I plug in any xy pair on this line, it makes the equation true. But I'm looking for the points that make both equations true at the same time, which means I'm looking for any points that lie on the graphs of both equations at the same time. There's only one point in this particular case that lies on both graphs, and that's the point 1, 1. And that's the one that we just visually by inspection real quickly said, oh yeah, that's a solution to the system. In this case, we can see it's going to be the only solution to the system because it is the only point that lies on both the blue line and the orange line at the same time. Okay? Let's take a look at one more example. Okay, let's look at y minus x squared equals 0 and y plus x squared equals 2. Okay, now, can we find a solution here? Well, actually, the same solution that we had last time works here. Right? So that's still a solution to the system of equations. But if we graph this, we'll see the situation's a little bit more complicated. So let me pull the graph over here again. So we have two graphs, y minus x squared equals 0. And we get this, your standard parabola. Okay. And then we have y plus x squared equals 2, which is a parabola that opens downward and is shifted up 2 units. All right. Now, from what we know, the solution to the system is going to be any point that lies on both equations at the same time. And we could see here that we actually have 2 points that meet that criteria. We have the point that we found here, 1, 1. But also on this side, there's another place where they intersect, the point negative 1, 1. So in this case, there's 2 solutions to the system of equations. So notice that this first system of equations, this is a linear system of equations, or a system of linear equations. It means the same thing. It is a system of equations where all of the equations in the system are linear. But this system down here is not a linear system. It's a nonlinear system of equations. And we could see that just intuitively, this nonlinear system of equations is going to tend to be more complicated than these linear systems of equations. In this class, we are going to focus on the linear systems of equations. They're easier to deal with, and they show up a lot in real-life situations.